Okay. I'm going to do a, let's see. We're going to do a impromptu talk about Factom and about blockchains, about what this technology can do, kind of an overview of things as I see them. I am pulling this off the cuff. It is going to be an amalgam of a bunch of other talks that I've given in the past, so please bear with me, and I apologize. I just simply want to give you a good bit of information about the blockchain as I see it, and hope to basically stimulate your imagination and your thought processes about where this cryptocurrency stuff is going. Okay, first of all, Bitcoin actually proved that something that we all knew was impossible is actually possible. Bitcoin provides one thing that is incredibly interesting to computer science people, and that is a distributed consensus algorithm. That means all the machines that are running Bitcoin nodes all have the same ledger. There's no central bank, there's no system of record. Everyone has the system of record and everyone has the same data. This was actually supposed to be impossible. But this was done using proof of work, which meant that you could not create Sybil attacks to vote for a fraudulent branch on the blockchain. And how many of you guys know what a Sybil attack is? A few people. A Sybil attack is where, let's say you get on the internet and you're going to have a vote on Facebook, and you say, if you believe Trump is going to win, vote yes. And you get 400,000 votes that say Trump's going to win. Did you really get 400,000 votes? I mean, we all know Facebook. Did you really get 400,000 votes? I mean, they have these click farms where they pay somebody to go run and click the right thing. Hillary Clinton had this thing called Correct the Record, which was a bunch of Reddit accounts that ran around and put pro-Hillary Clinton messages on various subreddits, right? These aren't real people. You understand what I'm saying? That not everything you read on the internet when there's 1 zillion likes, we all know that doesn't necessarily mean there's 1 zillion people that really like that thing, right? We all know that, right? I want to see a good yes here, because if you don't know this, you need to know this, okay? That's a Sybil attack. A Sybil attack is when someone can create a number of things that act like they are people that can vote for or influence something, and all they do is just like create replicas. Everybody know what a sock puppet account is? Raise your hand if you know what a sock puppet account. A sock puppet account is when you go on some social media and you create an account and you put a bunch of stuff in it so it looks like it's another person, and then like a sock puppet, you have that identity go and say stuff, and then you might argue with it, and then it might say something, and then you argue with it. So you have this whole conversation that to someone who's looking at it looks like a very valid exchange. You know, I'm for drug control. We need a drug war. We need to stop the drugs. No, you don't need the drug war. You don't know to stop the drugs because it's important that we burn down elementary schools and stuff. What are you, an idiot? Why would we want to burn down elementary schools? Because drugs are so much better than the elementary students. And what are you doing? Anyone reading this is thinking, oh, we need a drug war because look at this guy. He wants to burn down elementary schools and kill babies, right? But was there a real conversation there? No, it's a guy against a sock puppet to create the appearance of an argument. So this is another form of a Sybil attack. It's basically the ability to create entities to mess with things. And so in the computer world, when you want consensus, if you're going to vote on what is consensus, but somebody can create a whole bunch of votes to push it one way or the other, you can't necessarily get consensus. And so we didn't have a way to do that. But proof of work means that I can't create a computer and just replicate it, because they have to work really, really hard to have a vote. They have to burn a lot of electricity. They have to burn a lot of resources. If you have to burn all those resources to create a vote on a block that the next guy can just validate the transactions and say, well, that's not valid, and throw all your work away, then there's nothing to be gained to try to break the ledger. Because if you try to break the ledger, A, it costs you a lot of money, B, you fail. Let me give you a big principle on attacks on the computer. Attacks that are expensive and are guaranteed to fail do not occur. What's the point of me trying to scam you if it's going to cost me money and I'm going to fail? I just don't do it. I'm going to use a scam that has a chance of succeeding, and certainly I'm going to want a scam that's cheap. You know, I want a storefront to say I'm a company. I don't want to have a business with actual employees that are actually working. That would cost me money. Let me tell you a story about Factom. Factom is a company that I'm involved with, and I kind of invented the technology and whatnot with David as a instigator, forcing me, David Johnston here. Yeah, forcing me to do this. We were bringing in some new investors, and we had this guy come in, and he says, hi, so this is the Factom offices. And we said, yeah. And he was walking around, he's looking. And he said, this is the conference room? He looked at the conference room, looked at the whiteboard, looked at the mess, and we're like, I'm a little nervous. I'm like, we could have cleaned up. I'm sorry. I mean, I didn't expect you to show up here. He said, well, let me tell you a story. I went to go invest in another firm, and when I came in unannounced and I walked into the conference room, they still had plastic on the chairs. I did not invest because there was no evidence that they were working. It was a storefront and no engineers, nothing on the whiteboard, plastic on the conference chairs. He's out of there. Proof of work. If you can tell that you are doing something and you're spending money and you're working hard and you're making deadlines, sometimes missing deadlines, and there's all this evidence of activity, then at the very least, you know it's not really a scam because people don't run scams that way. It may be a failed business. I'm not saying that this is proof that somebody you invest in, but it is proof it's not necessarily a scam. I'll always put not necessarily. Well, this is the thing with Bitcoin. You put the proof of work on the block, it proves the transactions, then everyone that's validated starts working on the next block, adding the transactions and doing the proof of work on it. The chain of blocks that has the most proof of work is the chain that everybody else says that's the ledger. This simple algorithm proved that the computer science guys were wrong. You could have distributed consensus. Now, what is distributed consensus valuable for? Well, in the case of Bitcoin, it was to keep score. Just keep score. I have 10, you have 2. I have more than you. That's what Bitcoin is. Oh, you want more than me? I'll sell you 3. Now we're the same. You know, it's not any more than that. I transfer 3 to you. You now have 5. I have 5. We both see that we have the same. Oh, I want to send 2 to you. I send 2 to you. Now I have 3. You have 5. He has 2. It's just keeping score. What in the heck is the value of keeping score? Have you ever watched a Super Bowl? The score is pretty darn important. There's people around the world betting millions and millions, if not billions of dollars on a simple score. But why can they bet on the score? They can bet on the score because it's publicly auditable and it's guaranteed to a very strong, reasonable level of doubt that they got the score right. I say that guaranteed, and my eyes start rolling up in my head because I remember a certain movie with Jackie Gleason and Paul Newman doing what was the name of that movie? Was it The Hustler? The one where they set up the false racetrack game and the Sting. Yeah. So you have to go to great lengths, and for a very small locale, you can fool people about the score. But the point is, if you can guarantee the score between everybody, it has financial value. And the first time it had financial value was the purchase of 2 pizzas for, y'all, come on, you don't have 10,000 Bitcoin, which is only $40 million today. Good pizza, Papa John's. But the thing is it had no value until they purchased something. And then it started to have value because it was on an exchange and people wanted some of the score, right? Just some of the numbers. That's all they were, numbers. And then other people started to pay attention. The thing didn't collapse. Everybody said it would collapse. It didn't collapse. It kept going, and it got bigger, and it became valuable. So we now have Bitcoin, which for all intents and purposes is just an incredible way to track chips, track tokens, track score between people. And that's its fundamental thing. Now, if that was the only thing you could do with an immutable ledger, I don't know how interesting I would think that was. And so so people started thinking about what other things you can do with an immutable ledger. If you have an immutable ledger, this means multiple parties can coordinate their business processes. So I can start talking about how you could do land titles. You could do smart contracts. Smart contracts are really just posting in some sort of procedure that says if certain things happen, then I get coins, and if something else happens, you get coins, sort of thing, right? I mean, at the simplest level. Ethereum came out with this idea, Vitalik Buterin, he came up with this idea that we really need to be able to create very, very complex smart contracts. And so Ethereum was born, and Ethereum became the home of the ICO. How many of you have looked at the ERC20 token protocol? You've actually looked at it and its fields, okay? Not many people have. We kind of, the tokens, the ICOs, they roll off our tongue, but we don't really think about what it is. What it is a smart contract. It's a smart contract that these tokens provide these particular functions and functionalities, right? And they have a big list, and you create a token that provides those things, then you're following that ERC20 protocol. And that has raised, what is the estimate of how much money has been raised on Ethereum with ICOs? $2.5 billion, according, well, you're adding the unsold tokens as well as the sold tokens?
No, that's just money. No, that's just money.
Oh, wow. So $2.5 billion have been raised with these tokens. So Ethereum has this incredible application that it's really, really good for selling tokens. It's also good for a bunch of other things, but it has certain limitations. It has the same kinds of limitations as Bitcoin has in the number of transactions per second it can run. It has limitations in that as more people use Ethereum, more data has to be downloaded by all the clients, and that chews up disk space. And so there's all these kinds of limitations, and Vitalik is working very hard to shard Bitcoin. How many people know what shard means? How many people don't know what shard means and are willing to admit it? Okay. What's that? Shard. S-H-A-R-D. Shard. Huh? S-H-A-R-D. Shard. Huh? Okay. I think there was a joke there in my literal engineering mind. You know, here. Let me explain. He just said there's no T in it, and my problem is I can't spell my way out of a wet paper bag with a dictionary, and I'm sitting here struggling. Did I say T? I had to go through it. Is there a T in there? Anyway, so sharding is if I I got my zipper zipped. Okay, just checking. Sharding is in the blockchain world. I'm thinking through metaphors. Let me first explain what a blockchain is. Everybody understands hashing. Anybody doesn't understand hashing? One person. Well, hashing is 2 people, 3 people, and there's don't worry. There's 5 other people that would raise their hands, but they're embarrassed. Hashing is I can take any digital thing, whether I'm talking about a sentence, a word, a character, or an address, or a movie, or an entire database. I can run that through a mechanical formula processor thingy that we call a hash function, and I will get some number of bytes out. And the most common hashes that we use in the blockchain world are 256-bit hashes. I'll get 32 bytes of random values, just values. I mean, smaller than your address, right? 32 bytes. And that 32 bytes as a number is something that's like in the order of counting the molecules in the observable universe. I mean, it's a really, really, really big number. But data-wise, it's not that big. It's 32 characters, right? Everybody follow that? And the trick is, it's, for all practical purposes, unique for any input you put into the hash function. So if you hash something and it matches that hash, you can't find something else out there in the real world in any sort of reasonable way that would go into that function and produce the same 32 bytes. It's like a perfect fingerprint of a digital artifact. And so hashes, that's what hash is. The blockchain is a series of some sort of transactions or data. But what you do is you validate a block, you take the hash of it, you put that hash in the next block, and you add some more transactions. Then you take the hash of that block, and you put it in the next block, and you add a bunch of transactions. And you keep doing this. So the blocks are the block in blockchain, and the hash is what puts the chain into blockchain. It's chained with these hashes. So a blockchain is in general blocks of transactions connected with hashes. Does that make sense to everybody? Now the really interesting thing is if you have the hash of this last thing, since it includes the hash of the previous thing, it pretty much, the only way you can prove the hash is that this hash actually matches this thing, and this hash actually matches this thing, and this hash matches this thing. So Russian nesting dolls, do you have that picture in your mind? A little baby, a little mama, a little, yeah, Matryoshka. Did I say that right?
I think it's Matryoshka.
Okay. I'm not even going to try. But the idea is every time you add another block, you've added another layer of security, and the only way the hashes work is if everything is exactly the same all the way down to the little baby in the middle, from the great big Papa doll on the top, right? And that's the way the blockchain works. All right. So shard. So I have a chain of blocks. And I can put transactions in these blocks. But what I want to be able to do is not make you read all the transactions. What if I could take those blocks and put half a block up here and half a block down here and hash these along so that half of the data is up here and half of the data is down here. Now I've doubled the capacity of my blockchain, right? Because I'm building this bottom blockchain and I'm building this top one, and I'm not making anybody have to look at both, right? So everybody understands the concept of you take a candy bar, you break it in half, and you get half a candy bar here and half a candy bar there. Okay, I mean, it's complex stuff. Some of you all are engineers. I have to go slow, right? So that's what we want to do with blockchain. We have a big candy bar. That's heavy. That's too many calories. So we're going to break it in half, and we're going to run one up here and one down here. But we want more capacity, so we're going to break the halves into pieces. And this is sharding. Each time I can break and segregate the transactions into individual independent groups and run those transactions forward, I'm adding capacity to the blockchain, right? So that's sharding. It's the idea of how do I break the problem up. Here's the problem. You can't shard computation. So keeping score. If I'm going to give you 2 of my score in some arbitrary blockchain, right? And you're on a different shard, then I have to put my 2 from my shard into your shard. Well, that connects those 2 shards. Now I need to have some sort of cryptographic proof on one shard that says that's valid from the other shard, which very rapidly sucks both of them right back together again. So sharding computation is hard because computation occurs in context. Context eventually includes everything you've done in the past, which means you're sucked right back into the same limitations that you had before you sharded. So computation is hard to shard. The solutions have to do with independent third parties, independent voting. You begin to trust other entities to have done the cryptographic proofs so that you don't have to pull in that other chain. And this is really complicated, okay? And somebody will solve this problem, but right now it's very, very hard. So what we did at Factom is we looked at the fact that most of the problems that we have in the real world are not actually coin problems, and they're not actually computational problems. They're actually data problems. So if I'm looking at loan origination for a bank, and I want to do all the document management and document what I knew when and what information I used to make what decisions in the loan origination process, who surveyed the land, who did the tax assessment, who did all this, and get a completely cryptographically auditable loan origination plan. Did you hear a coin in that description? Where was the score? There was no score. I get a W-2, I put the W-2. If I'm going to use that W-2 for income, I put that I used that W-2 for my income in this loan app. And if I get the survey results and it's an acre and a half, and that's what I use in this loan application, okay, the taxes, right? There's no coin there. I'm not keeping score. I'm collecting documents and I'm pulling data from it. So it's all data. And the thing about blockchain is it's going to radically change how we deal with things in the real world, but the real world is data. And so what we did at Factom is we thought, well, then let's build a chain that just has data in it. So you can create, in Factom, a chain ID like Bob's chain, and I can put in Bob's chain his loan origination documents, and all those hashes are going along in Bob's chain, which has this Bob's chain ID on all those entries, okay? Now, it doesn't interact with anything. That means Bob's chain and maybe a bunch of chains that are mathematically close to it can all live in one shard, and they can always live in that shard because I'm collecting data and I'm putting into Bob's chain. Bob's chain will never become Ella's chain. Ella's chain's over here on this shard. Now, Ella's chain might have a reference to something in Bob's chain, but that's a data thing. That just says that's a data element that's in Ella's chain. Okay. I can create identities this way. I can say this is the David ID, and I can put information about David's ID in the chain, and I can create an identity there, and that identity can specify certain public keys, and then David can sign entries that are on a loan origination chain. It's all data. It's this guy signs this document came in here, I'm timestamping all this stuff. It's just data. All this stuff can go in its own shards. So I now, by getting rid of computation, I can now shard a blockchain. And I can create segments that can be used by any party for their particular application. And it's never going to mix with another chain unless I need that chain. And without slides, all I can say is we create, these chains are running this way. We're creating Merkle trees that go down to a directory block level that's very small, and it provides the cryptographic proofs of all this data we've collected. So when one shard needs to ask for the data in another shard, it gets the data, but the cryptographic proof goes to the directory block, which they are sharing, and the proofs still work. So I don't have to follow that other shard, I just have to get the data from it and then validate the cryptographic proof. Because it's data. Let me make this really simple. There's this application, probably a lot of you don't know it. It's called BitTorrent. Anybody heard of BitTorrent? Oh, okay. There's this other weird thing that started happening in the 2000s where there were kids that were downloading like music and stuff. Now you wouldn't understand that. They used to call it, they call it piracy or something. I don't know. And using simple protocols like BitTorrent, it appears that you can pretty much get anything Hollywood has ever produced and a few things that they haven't actually released yet. You know the scalability problem with BitTorrent, right? You know that there's a point where they won't be able to share Russia's movies, right? No, wait, they do. They won't be able to share Bollywood. Well, they do that too. There doesn't seem to be any limit. If somebody's willing to share it, BitTorrent works. Why? Because when you're downloading a movie, you don't care about anything else. You only care about that data. Think of anything you can share in BitTorrent as a chain in Factom. So now we're talking about the ability to pull down data based on some sort of identity. In a BitTorrent world, it'd be a torrent file. In Factom, it's a chain. Any way to pull out data, but with Factom, you get data integrity and time stamping, and so you know the value of your data, and you know that it hasn't been modified, it hasn't been changed, and that it existed at a particular point in time. This is all the stuff you need to know for audits. So BitTorrent's the model. Now, if that's the case, and we can actually create these data chains, and we can prove that they're all correct, what else do I have to solve? Well, one of the problems I have to solve is, how do I know it's really, really correct? I know the Factom chain says it's correct, but where's the Sybil attack protection? Well, we do this by anchoring. And that means that when we create a block in Factom, we take that hash and we put it somewhere where there is just no way anybody could modify, change it, or deny its existence at a point in time. And the most secure data structure on the planet is the Bitcoin blockchain. So we put the hash into the Bitcoin blockchain. And so every 10 minutes, there's a hash that's placed in the Bitcoin blockchain, and that provides the security for all this data, which means that what I told you earlier, that the only thing Bitcoin can do is move tokens around, was a lie. It can secure all the data in the entire world. It's no more limited than BitTorrent. You just have to have another layer to handle the construction of these data structures that allow you to create these cryptographic proofs, that allow you to query these data sets, and allow you to implement your applications and disrupt titling, disrupt insurance, disrupt banking, disrupt so many industries that are just begging for us to come in and implement some changes. So, yes, sir.
Just 3 minutes.
Yeah. All right. I burned through. You should have told me that there was time for questions.
Yeah,
but-
yeah, well, that's what I'm leaving time for.
Okay, 3 minutes.
No, we got 10 minutes for questions after the 3 minutes.
Oh, we have 10 minutes for questions after the. No, we don't. It's
Yeah,
2:37.
Yeah. Let's open it up.
All right. Let's open up for questions.
All right, big hand for Paul. That was great. All right, we got the first one right at the back. There you are, sir.
Hi, great presentation. I'm not an engineer. Could your network that you talked about run like an intelligent portfolio of, say, I don't know, 10 cryptocurrencies? Could that be run on a blockchain where somebody could say, here's $10,000 and I'd like the algorithm to automatically put it in the 10 best coins? or 10 coins that we name. Could that run on the Factom network, or should I go to the next room? Great question.
Well, it is a great question, but keep in mind that Factom is data. So we can create an audit trail that lets you document the coins that you've purchased in your portfolio and even do it in a way that is private so that other people can't look at it. But actually execute anything, that would be done at the client side. So you could build an application on Factom that could very easily do what you want, but it would actually be running on the client side. It would be running on your computer.
The accounting.
We would do the accounting, and we could even provide the cryptographic proof that your application was performing correctly, but we wouldn't actually be able to do anything because doing something means computation. See, Factom doesn't do anything.
Practically nothing is the quote. Practically nothing.
Practically nothing. Basically, think of it, if you ever get confused, think of BitTorrent. When you download BitTorrent, does it do your taxes? No. It doesn't do anything either. It just gives you the data. So this is what we do. We deal with the data.
Hi. Thanks for that explanation of Factom. I'm trying to wrap my mind around the sharding and I guess the reason for the segmentation. If you have a block, what is the advantage of the segmentation, breaking it down into those multiple different units?
It's really pretty easy. Let's say you have a 4-alarm fire, and you have 5 fire trucks roll up. How many of those do you want pumping water on the fire?
All of them.
All of them. That's sharding. If you want to do it serially, so one fire truck put ice water on, and when he was done, the next fire truck came, yeah, well, you might lose your house, but that's sharding. It's basically things that can be done in parallel provide you more capacity.
I was going to see, do you think you'll ever work with data.world? And if so, will Factom ever like kind of integrate that data or be able to use its user identity kind of solution in that with data.world?
I don't know data.world.
It's a bizarre, like the guy from Bizarre Voice just started it like a year ago. It's like it's like a data congregating site for all data across the world or something.
Okay.
Sort of a data aggregation site.
Data aggregation site. Yeah, Factom could definitely use it. I don't have any problem with any data application.
What does Factom look like to the end user? Like, do they open up a document and it says Factom secured or something like
that's what we do. What does Factum look like to the end user? It depends upon the application. We're building applications that use Factum, and that's what you see, a little green check mark. This validates a list of things with all green check marks. These things are in the data. And I'll be happy to talk to everybody more, but I'm actually out of time. And so I really, really appreciate you all listening to Trace Meyer's very, very insightful inside knowledge of Factum that you would have never expected.
All right, one big more hand for Paul. Here we go. Woo.